So we'll take a look at this process called logarithmic differentiation. So we're going to find dy dx for y equals 2 to the x. Now this is going to combine things that we did back in pre-calc with the ideas that we're doing with derivatives. So when we solve equations where the variables and the exponents, so remember solving equations with variable and the exponent, we had to use logarithms. And that allowed us to use property of logs to move down exponents. We will do that here to help us find the derivative of 2 to the x. So if we start to look at these exponential functions, remember, we studied things like we've looked at, say, x to the fourth, right? We could take the derivative of this by bringing down the exponent and subtracting 1 from the exponent. We had these derivative rules, but when the variable's in the exponent, the same rules will not apply. It will be very different. We do not have the power rule. The power rule is only for x to some constant. So here, the process that we're going to do is with logarithmic differentiation, we will take the logarithm of both sides. So I will take the natural log of y is equal to natural log of 2 to the x. Now, remembering your rules about logarithms, you can bring down this in front. So I have natural log of y is equal to x times natural log of 2. Now I can take the derivative. So this is going to be implicit differentiation at this point. I'm going to apply the derivative to both sides. So I take the derivative to both sides. So the derivative of natural log of y, we said in general, this always has the same thing where we do 1 over y times the derivative of the inside with a chain rule. So the derivative of the inside is dy dx. Now I take the derivative of x times natural log of 2. Natural log of 2 is just a funny constant. It's just a number. So I have x times a number. The derivative of x times a number is just that number. So here I just have natural log of 2. It's like the derivative of 5 times x. The derivative is just 5. So I now solve for dy dx by multiplying both sides by y. So I have dy dx is equal to y times natural log of 2. Now this could be fine, right? You have the derivative, dy dx by itself, but we know what y is. We know that y is 2 to the x. So I'm going to substitute that in here. So this says that my derivative is 2 to the x times natural log of 2. So that is my derivative of this function. So you could generalize this to any exponential function. Say a to the x, or you look at 10 to the x, anything constant to the x you could do this with. So let's take a look at this example now. This one gets a little bit uglier. Now we're going to have variables raised to variable exponents. We've never seen anything like this. You could try to graph this function just to understand what am I even looking at. So how do we deal with the derivative of this? Because we knew the derivative of, say, x to a constant, and over here we dealt a constant to an exponent that's a variable. Well, we're going to do the same thing we did over here and not worry at all because the power rule will not apply. The power rule won't work. So we do logarithmic differentiation. So I apply the logarithm to both sides. Natural log of x to the 1 over x. I bring down the exponent, so I have natural log of y is equal to 1 over x, natural log of x. Now that I have this simplified, now I'm going to do the implicit differentiation. I have d dx of natural log of y is equal to d dx of, in this case, I'm going to just write it as a single fraction, as natural log of x over x. Now the derivative of natural log of y, we know that's going to be 1 over y times dy dx. The derivative of natural log of x over x, this requires quotient rule. So we do the bottom times the derivative of the top plus the top, minus the top times the derivative of the bottom all over the bottom squared. So I can simplify this. So I have 1 over y times dy dx is equal to 1 minus natural log of x over x squared. Then I multiply by y, so I have dy dx is equal to y times 1 minus natural log of x over x squared. But again, we could substitute in the fact that I know y is x to the x. So this becomes x to the 1 over x times 1 minus natural log of x divided by x squared. So that is the derivative of x to the 1 over x. So again, if you see x in the exponent, you should be thinking logarithmic differentiation. Use the great abilities that logarithm has to move down exponents, and then you just take derivatives using your good old division or your good old derivative rules.